Hello everyone, this is educational material on engine fundamental, which is part 9. Focus on engine main component and subcomponent. The learning objective. After this presentation, the student shall be able to disassemble diesel engine component and subcomponent, which enables them study the diesel engine component. Identify the different parts of diesel engine according to this classification. The content. The content of this presentation material are engine dismantling and identification of diesel engine, stationary, rotary, and reciprocating part. The engine main component and subcomponent. Motor vehicle engine is a heat engine which produces mechanical power required to propel the vehicle. The engine is an assembly of many parts joined together to make it operational. Identification of diesel engine, stationary, rotary, and reciprocating parts. The diesel engine is an assembly of various parts. Each part has its own purpose. There is a combination of stationary, rotary, and reciprocating parts. Cylinder block, crankcase, and head. The picture shown here is the cylinder block of a diesel engine. Usually, the cylinder block of the diesel engine is bigger than the petrol engine. A distinctive feature of the cylinder block and crankcase construction for an automotive diesel engine as compared to gasoline engine. For example, the marine application is that the crankshaft under a slang from the upper part of the crankcase in petrol engine fashion rather than being supported from below on a bed plate. This is the engine designed for marine application. So the crankcase and the lower part of the engine block has unique feature comparing with the ordinary diesel engine. Likewise, the petrol engine. The diesel engine must contain the gas load, albeit of increased intensity, which strives to force apart the cylinder head from the main bearing below. In addition to the appreciable mechanical loading, the diesel cylinder block and crankcase must also be able to withstand severe thermal loading, and in view of current legislation, radiate the least possible noise during engine operation. As in petrol engine practice, the automotive diesel cylinder block is almost invariably cast integral with the crankcase, so as to combine the required rigidity with a reasonably low weight. For passenger car diesel engine, increasing use is now being made of a lighter weight cast iron known as compact graphite iron, usually abbreviated as CGI. This material offers about a one-third greater tensile strength and an improved fatigue resistance as compared to gray cast iron. However, it does call for more expensive high-speed machining technique to be adopted on production. The relevance of CGI to modern diesel engine design is that it either allows a lighter construction that bear comparison with an aluminum alloy, or its greater strength can be utilized to contain higher cylinder pressure in the interest of efficient combustion and hence improved emission control. The cylinder head. The cylinder head for a diesel engine is generally more complex in construction and has a more severe cooling requirement than its petrol engine counterpart. A one-piece cylinder head for an inline cylinder engine, and similarly one for each bank of a V-cylinder layout. A two-piece cylinder head, which means two separate heads, for an inline cylinder engine may still be used in the case of very large commercial vehicle application. Individual heads are of course employed for the cylinders of air-cooled diesel engine. Structurally, provision must be made in diesel engine cylinder head for incorporating a passage for each fuel injector, either through the medium of an inserted metal tube where direct injection is utilized, or by way of an integrally cast post to suit and direct injection. The latter system also requires the upper part of the combustion as well chamber to be formed in the cylinder head, whilst the lower half comprises an inserted machine plug that contains the thrust portion connecting the chamber to the cylinder. The materials used for the cylinder head. The cylinder head material for commercial vehicle diesel engine is a cast iron, except for some motor car diesel engine and also the individual cylinder head of air-cooled diesel engine, which utilizes an aluminum alloy. A high-strength chromium iron alloy, such as that developed by Medicyl and known as chromidium, may typically be specified. This type of material is characterized by an extremely high resistance to wear and corrosion, and careful control of metal composition enhance the pressure tightness of the finished casting. The following material specification for chromidium cylinder head iron is given by way of interest. The carbon composition 3.10 up to 3.5%. The manganese composition between 0.5 and 0.8%. The silicon 1.85 up to 2.4% is possible. The chromium 0.2 up to 0.3%. And the sulfur, the maximum is 0.15. And the Brinell hardness number should be between 190 and 240. And the phosphorus 0.2% is the maximum value. Engine piston differ from its petrol engine counterpart in the following basic respect. The first respect is increased sectional thickness of metal. The second one is longer in relation to diameter. And also the piston for diesel engines carry more ring. It need for top ring carrier and requirement for oil cooling of piston. Two-piece articulator piston. Increase sectional thickness of metal. This is concentrated in the upper portion of the piston for better heat dissipation and to afford the maximum possible support for the more heavily loaded gauge pin boss, in which the pin is made fully floating. To reduce thermal loading on the top compression ring, the piston top land is of increased depths. Temperature must generally be kept below about 200 degrees centigrade in the top ring groove in order to avoid ring sticking and scuffing problems due to carbon deposit and lacquer formation. A second land of increased depth is also provided to contain the higher mechanical loading on the top ring. Longer in relation to diameter. Pistons assume a trunk form to present a sliding bearing surface against the cylinder wall, which thus reacts against the side thrust arising from the angular motion of the connecting rod, making the piston crest relatively longer spread the greater side thrust force developed in the diesel engine over an increased surface area. Hence, the unit pressure is reduced so that separation between the piston and the cylinder wall is better maintained by the film of lubricating oil, and wear through direct contact it minimizes. The other comparison parameter and unique feature of the diesel engine piston is it may carry more ring comparing with the petrol engine. In long established practice, the diesel engine piston has generally been equipped with 3 instead of 2 compression rings and 2 rather than 1 oil control ring. More recently, however, there has been a definite trend to reduce the number of both compression and oil control rings to the same combination as that used in modern petrol engine practice. Technically, the number of rings used depend upon the severity of application and the projected design target for oil consumption, blow-by, and friction effect, the latter being related to fuel consumption. Need for top ring carrier. For naturally aspirated, which means non-pressure charged diesel engine, where cylinder pressure and temperature conditions are not too demanding, the piston may be simply of monometal, which means all aluminum alloy construction. Otherwise, where a more hostile cylinder environment is expected, the piston is generally of bonded insert construction, since the principal limiting factor of the monometal piston is ring groove wear. The insert is bonded into the aluminum alloy and form a wear resistant carrier for the top and sometimes also the second compression ring. It is made from a nickel cast iron alloy with hot expansion characteristics that closely match those of the aluminum alloy used in the main body of the piston. Requirement for oil cooling of piston. A significant proportion of the combustion heat to which the piston is exposed flows through the ring to the cylinder cooling jacket. The piston itself being cooled only by contact with the cylinder wall and a constantly renewing thin film of oil. which has originally been pumped from the sump. The reservoir of oil in the sump therefore acts as a medium for transferring excess heat away from the piston. This is a traditional way of cooling the piston. Let's discuss about the modern type of piston cooling using oil. Further use can be made on this particular heat transfer medium by arranging for a standing jet of oil to be directed against the underside of the piston crown. For this purpose, a series of strategically set nozzles. These nozzles receive oil under pressure from the main lubrication system of the engine and spray it up into the piston. This also permits closer fitting piston for quieter running. The picture shows the modern way of cooling the piston using oil. So this is the path of the cooling oil. So the cooling oil enter into the piston through this line. So it pass, or it is a splasher injected through, sprayed through these nozzles. So the nozzles spray the cooling oil, and the oil remove the heat from the interior part of the piston. So after cooling the piston, the oil return in this direction downward to the sump. Two-piece articulated pistons. A two-piece piston construction comprises a forged steel crown that carries the piston ring and an aluminum skirt, and therefore combines the best of both worlds. Because the steel crown better tolerates the high temperature and also expand less to maintain a more constant operating clearance for the ring, while the aluminum skirt, the lower part, still provides a lightweight means of guidance for the piston. However, unlike the two-piece piston used in marine diesel engine practice, where the crown is typically bolted to the skirt, those designed for heavy vehicle engines are of more compact articulated construction. That is the connection between the crown and the skirt. This is the crown and this is the skirt. So they are connected by pin. So that is the connection between the crown and the skirt is made solely through the guiding pin, so that the crown and semi-detached skirt are mutually self-aligning, with advantage being taken to minimize the running clearance of the cooler operating scheme. Crankshaft assembly and main bearing. Crankshaft. The predominant source of loading on the bearing of a diesel engine and hence on the crankshaft itself drives from high cylinder pressure. Under normal condition of combustion. Every is a naturally aspirated engine. Peak cylinder pressure can be up to about 10 million Newton per square of meter, which is therefore in the region of twice that encountered in the petrol engine, whilst for a turbocharged diesel engine, the cylinder pressure may be up to 40 million Newton per square of meter. Clearly then, a diesel engine crankshaft must be of robust proportion, and to this end, the diameter of the main bearing journal is usually made not less than 0.75 of the cylinder bore diameter, and the diameter of the crank pin not less than about 0.65 of this dimension. These values are of course at least on the upper limit for those quoted in section. Valve train and timing drive. Valve train. The valve train layouts for diesel engines are generally similar to those used with I-head petrol engine. For heavy-duty diesel engines, the valves are usually operated through the medium of pushrod and rocket, which receives their motion from a crankcase mounted camshaft with either tappet barrel or finger rocker floors. Less commonly, the valves of a heavy-duty diesel engine may be operated from an overhead camshaft, which either attack them directly via interposed bucket tappet or indirectly through rockers with the object of gaining either valve clearance adjustment. However, the overhead camshaft has been widely adopted as part of the valve train for light-duty diesel engine, such as used in passenger car. Comparison of diesel and petrol engine valve. In diesel engine, the poppet valves used are of the same established form as those described for petrol engine, but with more generous metal sections for the head and with noticeably longer stumps. The former is provided in the best interest of heat dissipation and mechanical strength, and the latter arises from the valve sitting in the bottom face of the cylinder head, rather than in the roof of a combustion chamber, as for most petrol engines. Although for normally aspirated diesel engine, the head diameter of the inlet valve conventionally exceeds that for the exhaust valve. Both valves are made equal in diameter in the case of turbocharged version, where energy from the exhaust gas is utilized to pressure charge the air induction system. Thank you for watching this video. If you are interested, please share with your colleagues.